In this video, I will show you what is 5G and how 5G works. What's up guys, I am Sandeep and you are watching Dual. For decades, the cellular telephone system has continuously grown in adoption and has evolved from simple calling and messaging to an enabling technology for universal wireless connectivity. This evolution has continuously involved the adoption of the additional frequency spectrum for the cellular wireless use, and this is no different with the upcoming 5G technologies. So, what is 5G? 5G is the fifth generation mobile network. It is a new global wireless standard after 1G, 2G, 3G and 4G networks. 5G enables a new kind of network that is designed to connect virtually everyone and everything together, including machines, objects and devices. 5G wireless technology is meant to deliver higher multi-perk data speeds, ultra-low latency, more reliability, massive network capacity, increased adaptability and a more uniform user experience to more users. Higher performance and improved efficiency empower new users' experiences and connects new industries. 5G is unified, more capable air interface. It has been designed with an extended capacity to enable the next generation user experience, empower new deployment models and deliver new services. With high speeds, superior reliability and negligible latency, 5G will expand the model ecosystem into new realms. 5G will impact every industry, making safer transportation, remote healthcare, precision agriculture, digitized logistics, and more a reality. How we got from 1G to 5G? The first generation of the mobile wireless networks built in the late 1970s and 1980s was analog. Voices were carried over the radio waves unencrypted, and anyone could listen in on the conversations using off-the-shelf components. The second generation, built in the 1990s, was digital, which made it possible to encrypt calls, make more efficient use of the wireless spectrum, and deliver data transfer on par with dial-up internet or later early DLS services. The third generation gave the digital networks a bandwidth boost and unshared in the smartphone revolution. The first 3G networks were built in the early 2000s, but they were slow to spread across the US. It's easy to forget when the original iPhone was released in 2007, it didn't even support full 3G speeds, let alone 4G. Meanwhile, Japan was well ahead of the US in both the 3G coverage and mobile internet use. But not after the first 3G capable iPhones began sliding into the pockets in July 2008. The US app economy started in the earnest. Apple had just launched the App Store that month, and the first phones using the Google's Android operating system had started shipping in the US a few months later. Soon smartphones, once seen as the luxury item, were considered necessities as Apple and Google popularized their gadgets, and Facebook gave people a reason to stay glued to their devices. Pushed by Apple and Google and apps like Facebook, the US led the way in shifting to 4G, leading to huge job and innovation growth as carriers expanded and upgraded their networks. What is wireless spectrum? The wireless spectrum refers to the entire range of the radio wave frequencies, from the lowest frequencies to the highest. The FCC regulates who can use which range or band of the frequency and for what purposes, to prevent users from interfering with each other's signal. Mobile networks have traditionally relied mostly on low and mid-band frequencies that can easily cover large distances and travel through the walls. But those are now so crowded that the carriers have turned to the higher end of the radio spectrum. Where is 5G being used? A defining capability of 5G is that it is designed for forward compatibility, the ability to flexibly support future services that are unknown today. 5G is used across the three main types of the connected services. Enhanced mobile broadband. In addition to making our smartphones better, 5G mobile technology can usher in new immersive experiences such as VR and AR, with faster, more uniform data rates, low latency, and lower cost per bit. Mission critical communications. 5G can enable new services that can transform industries with the ultra-reliable, available low-latency links like remote control of the critical infrastructure, vehicles, and medical procedures. Massive IoT. 5G is meant to seamlessly connect a massive number of embedded sensors in virtually everything through the ability to scale down in data rates, power, and mobility, providing extremely lean and low-cost connectivity solutions. The future of 5G. Now, after years of promises and years of waiting, 5G is finally arriving in consumers' pockets. The US Federal Communication Commission has held several auctions for 5G spectrum. There is more to 5G than mobile phones. 5G technologies should also be able to serve a great many devices nearly in real time. That will be crucial as the number of the internet connected cars, environmental sensors, and other gadgets accelerate in coming years. For example, 5G could help autonomous cars communicate not only with one another but also someday roads, lights, parking meters, and signals. And 5G's low latency means that 5G could enable remote surgeries, allowing physicians in one location to manipulate network-connected surgical instruments thousands of miles away. Medical providers may also be able to rely on 5G to rapidly transmit high-resolution images for use in the diagnosis and treatment. Manufacturers can use 5G networks to monitor production lines remotely and maintain video feeds for their factory floors. Some companies are licensing their own bit of 5G spectrum and are replacing their Wi-Fi networks with private 5G networks. And even though 5G remains far from universally available, the telecom industry is already looking forward to the next big thing. The technology that will take advantage of the areas of the wireless spectrum above 100 GHz, that is 6G. If you really enjoyed this video, make sure to subscribe to my YouTube channel right now. Just click the button below this video.